Hello, everybody. Whoa, sorry. Um, okay, I have to calibrate this. Good afternoon. My name is Bill Tang. I'm the co-chair for ESIP's Agriculture and Climate Cluster, along with Brian Wee, who couldn't make it. I'm not sure if he's online or not. For those of you who are not familiar with the cluster, I'll just give a quick 2-minute history. So we started in 2013 at the Chapel Hill summer meeting, specifically involving the USDA LTAR group, Long-Term Agroecological Research Network. And then we continue on with other USDA groups, the climate hubs, and also then moved on to the US Climate Resilience Toolkit group, working with them on developing case studies that go into their library, the database. And then last year, we did one of these ESA lab projects that still involving the CRT case studies, but looking at addressing the data to decisions aspect and on climate resilience. So that ended last year. And then we've always wanted to kind of move the cluster into the machine learning realm, and we just haven't had the resources and time. And then my colleague at NASA Goddard Space Flight Center, Arif Albarak, he has a strong background in mathematics and machine learning, so he was interested in getting this part of the cluster going. So that's how this planning session came about. So what we'll do is I'm going to hand it over to Arif in half a minute or so. So he's going to do a quick, I don't know, 5-10 minute intro slide talk, and then we'll from that point on we'll open up to the group to decide what is it that we want the cluster to do going forward in this area of agriculture and machine learning. Arif?
Hello, my name is Arif Albayrak. As Bill mentioned, I have a background in learning algorithms mostly. And so I will go through some of the important points, and after the about 10 minutes later, we will just have a small discussion between us to determine or get your ideas how the cluster and the machine learning together should go forward. So as you can see from here, everything is connected, linked data. Now, scroll. Okay. So recently what happened is that machine learning began to come up with all the proposals. Almost most of the NASA proposals has a component in it, some type of machine learning application or approach. And this is not only for NASA, for all the agencies is right now is coming up. And one of them is the very recent one from the National Science Foundation. So on purposely, I put this one here. This is quite a big lots of money in it, I will say. And if you click on that web link, basically you will go to this page, and there's all the explanations going through. Now, in this page, when you read, there's 4 or 5 items are very important items. So I just put them here. For example, some of the interests NSF has is the trustworthy AI foundations of the machine learning, but one of the item there is the AI-driven innovation in agriculture and the food systems. And certainly this is by itself is a very big a chunk of, how we say, dense information there. So we thought this will be a good time and opportunity to analyze the machine learning and the machine agriculture group and see what are the main components in here. We have been working on this similar subjects for some time, Brian, Bill, and I myself. So what I'm going to do, next 1 or 2 slides will be kind of summary of what we have done so far using machine learning. So, but also these examples will give you applications areas for specific problems. Now, one of the areas certainly you look into is the social media data. So you might say, what's the relationship with agriculture and social media? There's quite a bit relationship. So one of the study we did was try to find out the precipitation amounts, people sending tweets to each other, and what is the precipitation related information in these tweets. So we studied it. There is a 4 main section of this study. So for example, you look at the infrastructure, right? You have to put together the infrastructure very carefully to combine this data, let's say, with the global precipitation emission, GPM data. And so you have to consider what kind of databases you are using and what kind of, how you say, gridding maybe you are doing. It's depend on the level of the data you are considering. So if you go up here, there's a classification process. So people are sending the tweets, right? There might be a lot of different meanings in them. So you have to classify perfectly. So we were lucky, very lucky to work with 6 to 7 interns on this area. And they basically figured out some of the classification algorithms from convolutional neural networks to hierarchical attention networks, all of them, by the way, deep networks approaches, and generative adversarial networks. So basically, we implement all these algorithms up there and basically analyze them. Now, top of on this tweet classification, also there are some application comes. Like these applications might be, let's say, GPM anomaly detection. So what we look into it that we create, for example, surrogate systems runs parallel to the tweet world and try to figure out the anomalies. Now, another application we look into how we're gonna retrieve the information content. Actually, one of our intern now, she's working with us, Laura, specifically work on that subject. So as you can see, layers connects to the application world in terms of social media data. Another study we did with Brian and Bill was about we call it gap analysis for CRT plus. So in this case, what we look, actually, I focus on the documents specifically. So how are we gonna build the knowledge base from the given documents? This might be published papers. This might be maybe some of the documents we are receiving from the data producers, like ATBD, what they call, and so on. So we analyzed and we put together the small flow chart to see what are the components of this specific problem. Now, as you can see so far, we look at the social media data, we look at the knowledge base, building the knowledge base, but in terms of farm or in terms of agriculture, right, this is not the only 2 types of data you might receive. You might receive lots of other things. And one of them, actually, we were talking to, I don't remember her name, I think it was Jean. It's mentioned that they are using citizen science data. So this is another third option you might have, right? In the citizen science data case, what happens is that You use students, teachers, scientists. You put together a nice group of people, and they give them some type of tool. Sometimes that is some API in their phones and so on, and start to collect the information and maybe make them send tweets, right? And they receive that tweets and analyze that. And so NASA Globe program actually does this kind of studies, which is, and very successfully, by the way, all over the world. And they make their data available. If you talk to them, they will provide this information to you. So this is a third type of data source that might be considered. So basically, as you can see, there are lots of different data sources. So if we take there as a reference farmers, what the farmer wants to see in front of him, that is one of the simple questions we come up with, right? So we said in one of our telecon, okay, let's think about a dashboard. I give a dashboard in front of our farmer, and he will pull the components down and he will put together his data sources that he needs for that purpose. So in this case, for example, maybe he would like to know what's going on with his soil. Is it the quality of the soil for that year, and so on. The second one is the crop monitoring, right? He would like to know if he give enough water to the crop. And the weather monitoring, this is always, he wants to know every time if there is something crazy going on. So, by the way, I borrow the images from different companies. There are some work going on out there. So, one of the things I have a special interest is that I analyze satellite images. We have very high resolution satellite images, for example, from the Planet Labs. And NASA has a lot of resources like Landsat and so on. So actually we can get this kind of plots, but the farms are too small, right? If you consider, if you have a low resolution data, well, drones are flying. Now, data is collected by the drones. So looking up to this point, all these data sources I defined to you has different formats. And they all come different shapes and everything is different about them. So, but if we are talking about the decision-making tools, we have to bring this information into the, or maybe we need to harmonize them somehow. And I just put two more things there. Data from machinery is used in the farms. Now robots are collecting the fruits. For robots has the sensors on them. You can basically do a determination of the fruit quality using machine learning algorithms maybe behind it. And so some other type of sensors. Now, as you see, we have lots of different types of sensors, but also we have different layers of the problem. First, you collect the data, right? Now, all this data came from the different sensors, pull them into a similar format, or use some translators around them, and they create that similar format, and after that, look at the different levels of the. Now, you get a information, SO2 level is getting high in some other application. How are you gonna connect that to the knowledge bases, right? Today, there were very nice talks about the DB, Wikipedia type things, DBpedia, and so on. So, okay, you retrieve this information, now you need to connect to that database so that things will make sense. And we talk about the concept maps and all that things during the yesterday and today. At the end, this might be a very good application to look into how you can collect all these things. In the real world, the problem gets more difficult actually, right? And so this is what we're gonna discuss today a little bit. So I just try to put the general overview of the data sources and the levels of the information collecting and so on. So our goal next 5 months, I believe, until the summer meeting, ESIP meeting, began to put together the ideas and from these ideas try to get to a path that agriculture group and the members of the agriculture group benefit out of it. So, for example, if we think about that dashboard example I give you, it will be really nice to create a dashboard concept map. I just call it that way. I don't know if that is the correct way to say. That will kind of describe the connections between from that dashboard tool to the farmers, all that little layers in between. And when we do our research, right, or our products, we have to know where we are sitting. So first of all, we have to know what is our reference, right? Are we looking from the farmer side? Are we looking for the federal agency side? Are we looking for something else? So every time that concept map will move to different ways. So maybe this might be one solution, right? Another thing we have to be very careful, every single module in the dashboard has to be kind of independent from each other and linked in the backside. What that means is that if the farmer comes and I'm going to take this out and I want this data, he should be able to do that. And don't forget, this is a volunteer work. This is another constraint for us, right? We will just try to put together the ideas and see where that might go. So we cannot do too much maybe work, but we can put a base for the work. So I just throw there, Bill and I, we put these questions, 2 or 3 questions just to start the discussion. One of them is how we can harmonize the data to be useful for agro decision making. The method you use here is very important. Why is that? Because you want to intervene with the science is coming from, let's say, George Mason University at minimum. You don't want to change what is coming from there. What you need to do is just connect that information, link that information, let's say, our data sets in our archiving center, information and archiving center, so that they can be kind of combined together and serve to the computer science people so that they can run their machine learning algorithm on top of it. The second kind of very important subject, right, the metafiles will be hanging around, I will say, because it's each coming from different sensors and so on, and the dynamically, how you say, I call them updating metafiles, right? It's like if the guy changes, user changes one component to another, the metafile structure changes then. So how are you going to handle that one? That's a very legitimate question, I think. So that is something we should be looking into. And but most importantly, the work we're going to do should be complementary to the other works. I mean, if it's done out there, then you have a question, right? Why you are doing again the same thing? And we should bring something new with the actions we're going to take. So having said that, now I would like to open to you and get your opinions, and we will be taking notes, and hopefully next summer meeting we will have a good, how we say, roadmap in front of us. Yes, please. By the way, Eli will be taking notes for us there, and so we will make this information available to everyone.
Thank you, Arif. I'm Sudhir. I'm with the SRI, and This is my first time. I came a little bit late, so sorry if I'm asking question which doesn't make sense, but I'm trying to understand like the whole concept of the dashboard idea is that, so what kind of a dashboard you're trying to build and what kind of data that you're trying to pull, or is there something, some sort of like a schema that goes behind it, or?
So actually, dashboard is just a vehicle here.
So
Now,
is this the interface?
that's correct. So I mean, our goal here to find out what is the pieces and the architecture of such a dashboard in the back side of the dashboard will make all this data available to the user. So how are you going to link the data sets to each other, for example, right? When you say dashboard, it's not only what you see in front.
Mm-hmm.
If you're going to put the information to the decision making, right, then there maybe one type of a machine learning algorithm will come in, correct? So if George Mason people put some model data here, and another group comes in and says, I did the satellite image analysis. This is my classified images for this specific place, and so on. So now I want to take this and feed into the decision tool. You cannot do that, right? You cannot take the data sets like this,
So
and you
those
have to put together some link there. So this is just a vehicle to share the information with you.
So this is sort of, this will be sort of like request based protocol, or? Yeah.
This is Cindy Parr. I think what you're saying is that this is an exercise that will allow us to identify the pain points of doing this. We don't have a product here we're actually designing. It's sort of an armchair exercise to think through, what do you need to know? What do we already have? What's missing? And therefore, how can ESIP help move all of this forward? I mean, we may actually be able to do it.
That's correct.
But the first step is to figure out, what do you need? What are the requirements? How would you architect it, and what's missing, so that we can?
So,
yeah.
For example, I give you one or two, let's say Twitter data structure, right? Now, in order to come to the applications part, which are actually, if you think about it, it can be one component of that dashboard, each of them, like anomaly detection. And after that, maybe the amounts of precipitations and so on, each of them, right, sitting there. But what is that infrastructure we are putting together so that applications can be implemented on top of it? So dashboard idea in that case, as you mentioned, is just a vehicle or just a way to open the problem so that around June, we can have something that we can work on that.
Thank you. Okay, I do understand. So just a note, I mean, for those, if you're not aware of the Azure technology, I would definitely like to you think about some of the, we have built, and I definitely would recommend to take a look at it at least. You know, we have like a whole dashboard concept, but what the dashboard is basically just letting you use the user interface. What's going behind is like how you want that dashboard to be designed, right? For example, like I wish I could show you one that actually we actually built one for the we have project with the USDA ARS now with the Microsoft's FarmBeats. So what we did was basically, you know, there is a sensors getting the data from the field, and you know what they're doing is they're pushing the data through their API, and we are just calling those API and populating that data sets onto the back end of the dashboards, right? So the dashboard is giving me the sort of like, you know, heartbeat of whatever I want to show there, right? But for example, say if because like, for example, that has like a soil moisture sensor that gives, that are in the 3 different depths and collecting the soil moisture every 15 minutes, right? And then we're mapping those, but we also have the FarmBeats has the machine learning algorithm, which basically uses Sentinel data to interpolate. They have their own, you know, the algorithm, which will basically interpolate and predict the soil moisture in every 15 minutes on the farm, right? But the idea here is, again, so those kind of data that you can show in the dashboard, and if you look at the Azure dashboard, I will suggest like that is something sort of like a plugins, right? You will not have to program or code. It's very easily done. But
So that's a beautiful example. Right?
So, and if
And
that is the interest, I'll be happy to sort of be part of it and then share some of our use case.
that will be really nice.
So part of this exercise, I think, is looking at what's already there, because we don't want to reproduce something that already exists. But I think what I've heard is the idea of letting a farmer choose not just his own data coming from his own field, but other sources that they might pull in that would feed into the machine learning. And one of the things that I wonder if we have, and that would be useful to work on, is I know that our data repositories, particularly for agricultural data, don't have any sense of operational readiness. Like, we don't have in things like crop data an assessment of the level of confidence of the quality of the data. So I know that I've been hearing at this meeting that NASA has this, NOAA may have this as well, but I don't think we have it in agriculture. We have a lot of data sets, but we haven't done that formal evaluation of, is it ready for decision making or not?
I see.
So that might be something that,
I think this is
yeah, so
something important we can look into.
operational readiness levels are something that, like, I run a data repository. We don't have this for our data. It's mostly research data. It's probably not the best data to use for decision making. But on the other hand, there may not be any better crop modeling data. Maybe that's the best that there is. So that's something that would be
So
worked into this.
during the CRT plus studies we did, something interesting was how they are looking into the details in the farms. For example, the question was, there's a river going through the farm. The model changes. And what happens is that when you are doing search for similar documents, that is a very small but very important, actually, feature that there's a river in the place, and the topography of the farm, for example. Now, we have to start to think in that level to give a correct information. And also, there's another interesting subject, is that the height of the farm, let's say, the classification algorithm changes depending on that, the imagery you are looking into, right? If you are doing, there was a paper published for Nepal, for example. Is a totally different conditions than if you are looking farms in France. And so those are interesting areas to look into. So I agree with you on that. Any other comments? By the way, I'm going to make everyone talk today, so you cannot get away.
So do we know like where all of the data is that we would need to create this, or to even start creating it? Because that might be...
So in our case, right, we are the data center, and we have related data quite a bit. So I think we know very well our data set. So we know very well their formats and so on. And but that doesn't mean that the other sources, how they will be evaluated. Now, if you are collecting let's say, I will give you this example because I worked on it, Twitter data, and charging vectorizing this data, right? It's totally different format. So how are you gonna bring them to the same environment and fit into a decision tool?
Yeah.
So it's
Yeah,
a
I'm just
partial
thinking...
answer for you. It's just the ones we have, certainly we know, but we want to find out more about them.
So to add to that, so I mentioned the repository that I have managed, the Ag Data Commons. So we have a lot of the more specific agricultural data, some of which is geospatial, not all of it is, but we also have communities of crop modelers who are building databases of the kind of input data for crop modeling, but they're not using machine learning approaches. So there's a vast amount of data that they're already using for their non-AI models, and I think it would be really cool to bring that to bear into this machine learning context and see what we can do with it. So, so that's another source of data to combine with the NASA and other data.
So I was just wondering, what's your name? I'm sorry. Yeah, I was just wondering, for example, what kind of machine?
I'm Sudhir Shrestha.
I'm sorry?
Sudhir Shrestha.
Okay. I was wondering what kind of machine learning algorithms you are using behind the scenes.
So that is, we are in the process of, yeah, we are in the process of getting that algorithm yet. So that's the algorithm, something built by Microsoft, but those will be available in GitHub probably soon. But that is something good we shared, I think, but that's not ours.
Nice.
That's a, but that's a one algorithm, right? That it may or may be, that's built by Microsoft. It may or may not be open, but that is something we can work on. Maybe that's the project that we could work on, because there are data coming, there are similar kind of data available there to work on, right? So, but the idea, what I was talking about here was the whole concept of the dashboard, right? So there is also need of the data, especially like Cindy can talk more about that than I do about the USDA, but there are different sources of the data coming as well, right? But a lot of the data, for example, even the GPM data, right? That's coming, that's very valuable to the USDA community, right? For some of the work that do, right? And those could be pipelined here. But we're just looking at from the dashboard perspective, how you can actually visualize or sort of look at the data in the first hand, then the dashboard is already there, built in. What I'm saying is you don't want to spend time that is already there, but why not put that effort to do something else that probably I'll be interested to as well, be a part of that.
So are you saying the Microsoft platform, that's Azure or?
That's in Azure, but that's only about, I'm talking about the their analytics part, right? But the visualization part what I'm talking about is in the Azure platform. Yeah.
Actually, I think you just answered the question. So it is something that's publicly available.
Yeah, you can take a look at it. Yes.
Yeah. Okay.
Yeah.
Okay.
And I'll be happy to talk to you about that, Bill. Yeah.
What about the smaller scale sensors that that farmers might implement themselves, or just very local data that it might not ever leave their farm? So how would we, I guess that's a whole nother issue, and we're not even sure where that is.
So actually, with Laura earlier, we were discussing about Maryland University activities on this area. She kind of mentioned that they have a very big agriculture department there, and they working some of the farmers, let's say from Ellicott City and so on. So what we were thinking, I don't know if this can be happen or not, but maybe talk to some of the farmers who are using heavily, how you say, this type of sensors and so on, and invite them here actually, and get their perspective from this, because they are the end users at the end.
Yeah, and definitely include, I know the USDA has a ton of different tools, but none of them are integrated all together. And how much of that is
So that's
available.
part of what Esri is helping us with. But I also wanted to mention that a couple of years ago, OGC had a pilot project with soil moisture sensors that they were using to test drive their, I guess, their services oriented stuff. So we should dig that up and see where they've taken that and bring them into the picture here, because I think part of the problem with sensors is that it's all very proprietary. So depending on which sensors you're using, you may or may not be able to combine it with other sensors or other platforms to get access to the data, unfortunately. And so OGC might have a better.
Actually, this morning I listened to their talk and they mentioned that.
Oh, did they? Okay. And it's still
examples.
a problem, right?
Yeah, it was one of the examples. Basically.
Yeah, so there is at least two, probably more efforts that I know of where organizations are trying to sort of break that industry logjam by public-private partnerships, I guess, to try to convince everybody to make the data cross-compatible and share. And it's similar to the efforts that are going on with drones, with UAVs. And so there also has been a group here at USIP that has worked with UAV data for similar reasons. And it's the same, that's something else to throw in here, is that you've got sensors, you've got drones. None of this is easy because it's not designed for research, and it's not designed necessarily for decision making on a large scale. It's designed so that a single company provides its information to the farmer who paid for the equipment, but they're not combining it at the scales that I think we would like to be able to do for this. Or if they are, it's proprietary and you can't benefit from it.
Thank you. Any other comments?
I just wanted to point out on the decision-making part. So for the farmers, when you say that they want to use this tool for decision-making, I think it is important to keep in mind that decision-making on what scale, right? So a farmer wants to know like how much water he needs to irrigate tomorrow or in a week, versus he also wants to know what he wants to do for planning next year. So I think when we design such decision-making tools through machine learning, I think it is important to keep that mind, like, on various time scales. So that it will be useful to, in a wide variety of ways.
Yeah, I think we took note of that. It's kind of which level of decisions and for whom and all that little details, which is very important how we're going to plan this session next year. So.
Given you only have 5 months, so what's the goal? Like how many application like dimensions you want, use case dimension you want to focus on, like drought monitoring or the like disease monitoring or different things?
So the first thing we will do, first of all, certainly we will talk to experienced, for example, you mentioned that you already implement some of the pieces of the problem you consider in terms of dashboard. I think we need to look into a little bit these things and how we can augment this kind of products. I don't know if this is the correct word to say. As we say before, we don't want to repeat the things. And in our case, we are very much interested in with our data sets, how we can make these data sets such a way available, what kind of format and so on, how we can make this data set available so that it can be used directly by anyone, let's say, who's creating a dashboard. And I think, so as a data center, this is one of our major goals, right? Usage of our data sets. And that's why we are trying to figure it out. So we are in a new environment now that, as I mentioned earlier, every proposal, including the machine learning in it as one of the item, right? So how we can take our resources and make it more usable, and so on.
So I think there's two ways to approach it. One is to pick up on your idea that there's actually many possible decisions a farmer might want help with. And there's also already plenty of, or several, multiple machine learning approaches to solve particular decisions. So the question is, which ones, are they not good enough? Should we focus on the ones that we think could be improved more? Should we focus on the ones that have never been tried with machine learning before? So it looks like we need to sort of do an inventory of, well, what are the kinds of questions that a dashboard like this might help a farmer with, but then also which ones already have some progress on machine learning approaches and which ones have nothing, and where is our, what can we do that's complementary to what's already out there?
Another angle to look at it is that because different region, the farmer might have different needs, because like in California, the farmer will having different challenges than the farmers, say, in Midwest. So then probably focus on one region would be more, it would be easier within this time frame to focus on, to identify some priorities to work on.
So one quick, just advice, I'm no expert in this one, but definitely I would like to say, for example, some parameters. I'll again stick to the soil moisture, right? Soil moisture, the amount of soil moisture you will be needing for germination of certain seed remains the same, right? Whether it is in California or somewhere else, right? If you come up with an algorithm that works in one place where there is a requirement for germination, there is a certain temperature, certain humidity, certain amount of soil texture or what kind of soil texture it is, certain number of solar radiation, right? All those factors in. If you have a model that works for a particular species of that, crop, then it will work regardless of the location, right? Because that's just a matter of the physical parameters, how it influences the germination of the particular plants. So isn't that something to think about? Like but maybe the model that you build in one place, that is a replicable into other places as well. But maybe like a very small, maybe a couple of species wise or something different. Just a thought.
I just want to make sure that I understood. So when you said when you factor all these things in, then it doesn't matter where you are. But factoring is implicitly accounting for the differences in geography, right? So the set of factor in California versus the set of factors here will dictate actually different amounts of soil moisture needed to germinate a particular crop because of all the climatic variables. So is that consistent with what you just said?
No, sort of, right? So what I'm trying to say is like, it's a model we're talking about, right? So when you're building, so if it is something, the motto of this group is to build a model for machine learning, right? So, and that's the whole idea of a machine learning model as well. If you could develop in one place and if you see if you can implement somewhere else and how well it does, right? That's the idea. Otherwise, like it will be like otherwise it will be the purpose of having using the machine learning capabilities. Otherwise, you'll be doing manually from all the locations. But what I was saying is like if you're trying to build a model for, say, I'll just stick to like a one variety of crops, right? But it has all the parameters like environmental parameters and then the physical parameters that you're going to consider for that particular model, right? The only thing it would change your geographically will be your all those parameters, which, for example, like a soil moisture and those content will change, right? But those are just those are not the empirical models, right? Those are like a physical characteristic that can be changed. But if you build one model for one place, that should be able to adapt to another. If I'm making sense.
So now I have been thinking your comment now. You are fixing that whatever you see it, right, it will come out and the conditions should be similar to. Now, maybe the model will be same, I agree on that, but you have to consider, I think, you have to consider that conditions will not be same everywhere. Yep. And under some conditions, right, so in terms of machine learning, you will have maybe different set of values in your future vectors. But still you will train one model under. So the difference will come from your different features feeding into the system. Yeah. Now, that doesn't mean it will be successful, non-successful, right? It will be a little bit different maybe. That's why, for example, we have a grass seeds different in Los Angeles than here. So USDA works on that quite a bit. And I do agree, it will be one model, but certainly the conditions will change. So the clusters you are fitting into your system will be different, even though their answers might be similar. So that's from the machine learning side. Now, if you have anyone from USDA, they can give their side too. But that's what it is basically. So I agree with you on that, at least that part.
So I have another question. I think that there are kind of two different things that we're talking about from what I am getting from my notes. It's like we can either be the ones asking questions of the data, or we can be the ones making sure that other people can ask those questions of the data. And are we, I guess, which one are we trying to do? Like, are we the ones making sure that there can be machine learning done on the data? Or are we assuming that that's already happened and stepping to asking the questions for June, like in June?
Well, that's a little bit difficult to answer because I will explain why. When we talk about at the early stages of the talk, what we said, we are looking to the how we're going to link the data sets. I think it doesn't matter from which angle you are approaching, which, by the way, I agree with you. That's a very good observation there. That links will be similar structure. And so the question comes to this, something I think we need to sit as a group, sit and think about it. How that links will be built. And if it's going to make any difference, like in your, like the question from this space to that space. So there's something we should be looking probably these next several months into. That's a good question.
My answer to that is I think in this group we have people with different expertise. My expertise is in making data available for others to use. Your expertise may be in machine learning. And so between the two of us, I want to know, what can I do to make my data better for you? And it may be just discoverability, making it findable, or making it selectable, or making the format clear, or making an API to it in a way that you can use. I mean, these are all possible questions. I know that at the federal level, we're looking for ways that we can improve the AI readiness of our data. And the best way to do that is to try using it for AI. But then there's another angle, and I think that goes back to the farmer. What do farmers really need? Let's focus our attention on use cases that are actually oriented to the kinds of decisions that farmers want to make that they can't currently make, or that they have to pay a lot of money for and they can't afford to do that, or they don't trust the decision. So another comment I've heard is that there are a lot of companies out there who now sell decision support products. And how do you know that they're providing good advice? There's no oversight. They could be using some model that isn't really a good model, and how do you know? So is there some way to certify algorithms that we know some are better than others, or that the underlying data that goes into those models is better than some or not?
I think it also goes to another question, which is uncertainty of the data and the uncertainty of the information you provide for the people who need to make decisions on grounds. So there are some applications using machine learning as a tool to identify the uncertainty of different data. So that's another aspect, but I just don't want to throw too much topic on this plate at this moment.
Yeah, that's an important subject for every, I think uncertainty is.
So just listening to everybody, so I wonder if this is something that, whether it's already done or not, or if not, was it something that we can take on? It's like, given, say, a particular user of the dashboard, right, typing in the requirements, the desires, and then at the back end, we provide the kind of the, not a search tree, but what is that?
I didn't hear you.
So it's like what machine learning algorithm is suitable for a particular case, right? So farmer says, well, I need this, I want to do this. And what is the recommended algorithm to use? So right now, I don't know if that's existing in any of these systems, or whether anybody had done that. I mean, the other I've seen decision trees where you type in, well, I want to do this, and you go down the tree and eventually say, well, use this. That's a recommended algorithm. So maybe that's something, potentially something that we could
Actually,
work
that
on.
looks like one of the study we did earlier with Laura.
That's what we
Yeah, and we don't want to say we recommend it, but This is maybe the most used method. Recommended is kind of risky there. Anyway, but we did something like that. This might be the document analysis of this, agriculture group study area. Maybe this might be helpful for the dashboard approach that can, augment their work. And yeah, I think that's a good idea. So basically, we will continue with this work next several months, and we will look into the details and try to understand what are the best approaches for this, or how we can approach this problem under the given conditions to us. And I strongly suggest join our telecons if you are not, and considering that all these proposals are coming, and obviously there's quite a bit need out there, this might be a good preparation for everyone. So this might take us from discussing if we should use cloud or not, from that to maybe much higher level, more applicable applications. So we will be around today, tomorrow. If you have any ideas, please just join us and just find me outside. I'll try to answer, or Bill. Thank you very much. Bill, do you have anything?
Well, yeah. So, do we have, or has the discussion gone around enough for us to, leaving this place, agreeing on what the immediate next thing that we all want to do or work on immediately, and also looking ahead to the summer ESA meeting in July. Let's say we have a session plan that will report out on whatever the group as a whole might be able to do in the next 5 months. Because I think it'll be useful, important if we can do that, so that once we go back to our respective places, to have something that we can all already thinking about, that's commonly agreed on, that's something doable, that's interesting, something that everybody will be willing to do volunteer work on. So do we have some kind of consensus on what that doable thing might be between now and July?
I don't think we're quite there yet. Maybe we need a little bit more work. So, for example, I was thinking you have monthly calls. So there's only so many months. There's not a lot of time to do things during a call, and in between calls, everybody's busy. So we need something, next steps that are focused. So I'm going to just brainstorm. So one thing we could do is make a list of dashboard use cases, decisions that a farmer might want, or features of a dashboard that they might want. That could be one activity. Another activity could be to quickly, and maybe you're the best person for this because you're the most experienced at machine learning applications, make a list of cases where there are interesting approaches to machine learning solutions to those use cases. And then a third list of what are all the 4 lists, okay. Obviously data, what are the data resources that are needed or that are missing, or both? And then the other one is, what are the problems? What are the pain points? Where are we finding issues? And that doesn't necessarily mean that we have to deal with all of them. So for example, I have a parallel activity working on codes of conduct for working with farmers on data that could be highly sensitive that they don't want to share for this kind of activity. But we want to come up with a way to encourage them to share. That's probably out of scope, I think, for this group, but it's a problem and somebody needs to work on it. But so we may identify a bunch of problems, like I think you mentioned scale, and formats. These things are all going to be issues when we try to put the data together. So we could have a list of problems and then in the monthly calls, narrow down the lists to things that we can actually try to work on.
One other item relating to the complementary aspect is maybe to compile a list of existing efforts, such as what Sugir mentioned, what everybody else has already been doing, and so that just to make sure we're not duplicating anything, and that whatever we do is actually kind of uniquely suited for ESIP to do in this cluster in particular.
And
So
actually,
for
we
our
can
note
put-
taker, let me just make sure. So I think what you're saying is a list of existing dashboard efforts. Yeah, okay.
And also we can link them to our maybe website, like your work, for example. You have the best experience on that, right? So if someone looking into that subject, they can directly, there it is.
So I'll have to ask permission from the USDA if I can share that or not yet, but I'll work on it. So it's, right. So, but definitely, but so what I was talking here is basically, this is one example, right? So it's basically it's a whole app. The concept is a reconfigurable applications, right? So this is what I'm talking. This is one example. You can bring in anything on that analysis part into that dashboard, right? Dashboard is just the front end, right? The back end, whatever you provide, that's what it's going to give it to you, right? That is much more sort of like interoperable kind of, the dashboard. So, but what I wanted to ask, so I work with Johan in your machine learning cluster, but I wanted to actually see what specific questions we're trying to solve using machine learning. I'm interested to hear that, what you're trying to do in the machine learning side in this cluster.
So right now, what we are trying to do are two things. One is the building the tutorials, the training materials with data management clearinghouse, and that will be focused on earth science applications. And the other part will be, now we are focusing on the labeling, the training data set. So like in the previous like AI session, that couple speaker all mentioned that the training data set has like, it's basically it's very important aspects of the machine learning model, like building process. So, and like tomorrow we have like a back-to-back session on different tools that people can use and combine with the crowd sourcing platforms to do the training data sets. So this is like two focus right now in the machine learning cluster. But if there's like active like members focus on other things, that can be other activities as well.
Sorry, I'll be here tomorrow, but like definitely I'll be interested to see if there is a even so this is tutorial about how to use machine learning, and it's a very general then.
Will be with open source code, anything like all the things the concept we try to build these tutorials to have two, one high level and one more detailed technical level. So for high level would be those who do not necessarily want to implement the technical work themselves, but want to understand how the whole workflow works for machine learning. And then in that like tutorial, you can click on the code and then get into really detail of how you implement different machine learning, and with open source.
Right, but what problem, what example that you're gonna do?
We have like right now there's three tutorials in the queue of building. One is the air quality for the PM 2.5 concentrations, and one is the land cover classification from Earth observations, and the other one would be the time series prediction that we haven't identified the physical variables we want to do for that application yet. So if that maybe there's a collaboration between the machine learning cluster and the agriculture, that there's so many time series data from the agriculture side that we can build our tutorial on that specific data set for time series prediction.
Okay.
So one of the things, actually, I'm by the way, I work with machine learning group too, and one of the thing over there, we look into these data repositories out there. Now, ESIP, we cannot we don't have place to put data, this kind of things. But what we can do, the idea was at the time, how we can kind of link these repositories. Like Johan looked into a lot about the APIs, for example, reads Kaggle dataset or UCI, right? If UCI dataset. So there are APIs written out there already. So can you bring them to a, let's say, testbed or something like that that you can use and make available to ESIP? Not the data sets, because those are big things. You cannot move them around that easily. But what you can do, right, maybe provide an API, right, or show where the APIs are to the community so that just community can go there, get the API. Now they have a full, how we say, connection to data set. And are you familiar with the Kaggle, for example? Yes. They have so many different data sets and really nice data sets. It's just community work on it. This is the nice thing about the open source, open data, and the people, everybody is pitching in there. And so there it is.
No,
that's something maybe.
Because I thought this is sort of like an agriculture sort of domain. I was interested to see if there will be any examples that uses some of those, those in the domain of the agriculture as well. That will be of interest.
That's a very nice question, actually. For example, recently we looked at for the soil quality. There was a whole data set is there already. It's just labeled for you. And they were using some type of sensors to figure that, not just opening a hole on the soil, right? They were using some type of a sensor. I don't remember the top of my mind. But they give the full data set provided to users. And basically, there was a competition about it. There's the result of the person who got first, second, third in the Git repository. So you can get their codes, basically. You can implement and use the data. So those are all out there. And related to agriculture, there's a lot of stuff. There's forest-related data in Amazons, these, that, just imagine. And they have image satellite data. Sometimes the ones you cannot find, the private company provides to Kaggle. It's open. Just take a look at it. If you can do classification for the, let's say, maybe, I don't know, their products and so on.
So one example of someone using machine learning for an agricultural application is from my department at USC, South Carolina, not Southern California. One of the professors is using machine learning and a series of sensors to look at drift.
Chris?
What?
That will be Chris.
Risk?
Who is that person?
Oh, April Hiscox. She is looking at drift during the evening when the stable boundary layer is created on farms. I'm not an expert at like microclimatology at all, but basically one of the things that happens with farming is when they spray pesticides, there's a huge concern with that drifting to other parts of their fields, other people's fields, a lot of that. And so they just collected a ton of data over this past or last fall, and they've now been processing it and trying to use machine learning to be able to predict when that drift is going to occur, because we don't really understand why that occurs or when it occurs, and it's not necessarily as intuitive as we thought. So that's an example of one.
Like, sorry, I talk too much.
That's good, you can.
So, but I think like, for the agriculture domain, like cluster like this with the machine learning, I think maybe it's an opportunity for us to try at least one example. And we have folks from USDA, and I've been fortunate to working with some of the projects on the USDA we can bring in. I also work with the NASA folks as well, and NOAA as well. So, we definitely can see if we can work on at least one example that we can share, and probably we have a domain expertise from USDA as well to do that. That would be of interest. But I will still be interested to see if there is something that we can do on the soil moisture domain. That's just one of the like a biggest thing, right? Because
actually, from NASA, we know several people, they specifically work on soil moisture with a interest machine learning algorithms
Right.
behind it. Maybe we can bring them to board if they have time.
Right, sure. I think I'll be interested to invest my extra time not paid by Esri on that one, for sure, if
Yeah,
that is of
that's
interest.
certainly.
Yep.
Another question that has come up, well, speaking with farmers in the South, is with all these hurricanes that have been coming during the harvest season, is whether they should harvest or should not harvest, because it's a very specific window of time where you can harvest. And then, for example, like peanuts are sometimes like the knowledge that they have from just having been farmers for decades and generations is it's better to leave the peanuts in the ground if there's going to be a flood. But that might not always be the case, and they found that that's not always the case. So whether to harvest or not, depending on the time of year and the soil moisture and the likelihood of the water that ends up on their field being saline versus not saline. I mean, there's a whole lots of concern and not very much happening around coastal agriculture. So.
Yeah, I think that's a very good point. I have a comment on that. I think the machine learning or the AI community think that it's not universally applicable. So recent paper on Science, I think they mentioned that completely replace the existing modeling, all these existing facility capabilities with AR is not possible. So we have to integrate the existing modeling, like the existing knowledge we have already accumulated in the past maybe decades of farming, and how to integrate that knowledge and models with the machine learning models is the next big step of the whole community. I think for the entire science community. So integration, not a replacement. That's my point.
Well, I do agree with that, by the way. We have several studies before, and we ask questions like, is this a retrieval or it's a bias correction? Now, if it's a bias correction, then you're augmenting your model, right? This is what I will say. And if it's a retrieval, then you are just replacing the whole model and you are doing the retrieval process, basically. So this is another thing we should look into. I do agree with the comment, by the way. That's
Going back to action items, it sounds like what we are talking about is more kind of like surveying white paper type of work for the next half year or even a year to figuring out what's the existing knowledge there and what's the gap between.
I think we can do the planning for maybe one application to be.
Yeah, I was going to say the same thing. We could do a survey, but I mean, we're already quickly building that list of use cases. And so within another month or two, we could pick one that we think hasn't yet been addressed or could be addressed better, and we could focus on it. And things can happen in parallel.
Yeah, one or two. Soil moisture next to that peanuts. I don't know. I mean,
So
that might be an interesting combination there.
So the monthly telecom for this cluster is the first Tuesday of every month, and we're going back to 3 p.m. Eastern.
Is there
Okay, good.
is there someone we can ask that to request to add us into the cluster?
Yeah, I can send that information to.
You can just sign up on the EAST website. There's a cluster collaborative area, and then you can find the agriculture and climate and just sign up.
Right. Yeah.
I will get your information too. I will send privately.
Right.
Or
So,
anyone wants to.
so maybe we should aim for the February telecom to narrow this down to an actual something that we can then actually work on for July.
Sure.
So maybe that's the action item we take away from today.
And so, Johan, you said you're planning to build the one for the vegetation land cover classification. So there is already, I don't know, I can point you to that GitHub as well. So Noah and we worked on one of the classification for the nape imagery. using the some of the vegetation classification, and actually Microsoft went ahead and did it in the full, and it comes with the full code and all the instructions. So you may or may not have to build one. You can just pull that and
Yeah, so it's not specifically for one application. It's more just like the type of work. So machine learning would be like prediction, regression, classification, and then time series prediction. That's like 3. So for the classification, we just pick the land cover, but we can also, if there is really like comprehensive ones, that we can try to pivot that to other.
Can you keep me in the loop of some of those that you're
Yeah,
building?
sure.
I'll be happy to help on that.
Sorry, I was delayed and missed most of the discussion. So if I'm asking something that was already covered, I'll go eat something outside instead. In the portion that I heard, I have not heard anyone identify who actually is interested in the answers to these questions. Is there a real user that wants this? Or do we have a tool that we're now in search of a problem, or do we have a problem that's in search of a solution?
So this is a planning section.
Okay.
So actually our goal is to find the interested parties. For example, we bring the problem here, agriculture cluster working for some time, and they depend on the, how to say, the items we got there. Maybe next time, summer meeting, we will start to invite the interested parties. Maybe if we can find maybe farmer, maybe from the agencies, someone from USDA, or the scientist who is writing all these algorithms. And the goal here to bring them into the same place and have the discussion and move on. And we are in the, for example, NASA guest disk. I'm working in the data archiving center. So for our interest here to find out for maybe data formats for the machine learning preparation. So goal basically to understand what is the need and try to find that interested parties and bring them here to have a much
Okay,
larger.
thank you for the clarification. The follow-up question, regardless of the clarification, was at what scale are you working, and what scale is the data available for? Because if the question is, what do I do in my field, where the trees are, where the fence is, where the neighbor's sensitive crops are, is probably as important as what is the barometric pressure at the nearest airport, or other information that the farmer would not have to be able to put into the decision-making tool to be able to assist. I think you said that there was data from the fall.
Oh, that was just an example.
Okay, well, an example there is, okay, what about spring and summer? And there's no reason to believe that fall and spring and summer are the same. And I would argue that they probably are not. I'm not a farmer, but I do work for USDA and have enough common sense and sense of weather and climate that they're not the same. Maybe the thing to find is some area that somebody has been researching and studying. They've already done the lit review. They know what the model results are, and find something that you can improve, or where there's a machine learning component that might be valuable as an add-on, instead of just trying to choose a problem. I don't have a good suggestion of what they are, but Sudhir, you probably have good contacts, as to who might be willing to collaborate in that way. Yeah.
So is it the problem, right? Well, I think.
Basically, let's see if I understand correctly. So someone work on subject X, they already have the model for it, but they are not applying their model in terms of machine learning approach. So it's like kind of a model replacement, or maybe
There's a
something
supplement
like
or a synergy
Yeah.
You know, it's not so much of a replacement. Maybe there's, I mean, all models make a lot of assumptions, and maybe there's a machine learning approach that would better support the assumptions that are feeding the model and therefore get
Exactly.
a better result.
We have been talking about the soil quality. And for example, they use the models to predict the, whatever they are looking for there. So there is no machine learning application on top of it. So there it is. This maybe we need to get into touch with them and they take that problem, kind of adjust to our way. Not our way, but the cluster.
Yeah. The soil quality.
As an example, I just gave.
Well, as an example, yes, a lot of the soil quality depends upon what you've done for the last 10, 15 years.
That's correct.
You know, what was the crop last year and where are you in your model, or where you are in your cropping plan?
Exactly.
So there's an awful lot of additional information.
Yeah. So actually, in the data sets, especially for the training data sets, you always try to include different frequency of future vectors. Yeah. So some of them is the low frequency, maybe, like generally soil moisture change is a low frequency signal, while the rain is the high frequency signal there. So if you are talking about the, let's say, floods, right? That happens, let's say, around the Houston area with the sudden rains and all that stuff. So you need to include all that components in the different frequencies. Now you are trying to estimate the soil, how to say, wetness, whatever. Then your whole system little bit will move towards then what is your low frequency, right? So those are nice things to look into.
I come from a different perspective on things, and I'm hoping that's an advantage
I think so.
and not a disadvantage.
It's like ensemble prediction, right?
Yeah.
You want different initiations, so then the system will stay started. So I think we can wrap it up, and if there's any questions, we will be here, right? Okay. Thank you.
And what I can also probably take a note as well. So in Esri as well, we have lots of machine learning tools now. So I'll definitely encourage you to. So I'll be happy to actually, I would love to see you use our tools to do some of those and use the use case. I'll be happy to actually collaborate with on that, actually. Yes. And the idea will be actually, this will become a tutorial. So that would be great, actually. Yeah.
Okay. Yeah, I think we're done. So again, next, the first Tuesday of February of every month, so next time is February, 3 p.m. Eastern, we will have our telecon. So we'll aim for that time to narrow down to something that's we're going to be working on towards July.
So that will be February 3rd?
Yeah, whatever that Tuesday is.
Tuesday.
No, first Tuesday. Yeah, first Tuesday. Yeah.
February 4th?
Great. Well, thank you, everybody.